Hello everyone. In this lesson, we will continue with the operation of the NX-MCD module. This case is one of the basic introductory cases that simulates a production line where unassembled materials are transported by conveyor belts, transferred across distances on left and right parts of conveyor belts, triggered by sensors to transform into assembled materials, and finally collected at the end of the left conveyor belt. We will cover the following topics. Learning objectives of this lesson. 1. Master the application of basic toolbar commands such as rigid body, collision body, conveyor belt, and object source. 2. Achieve the simulation effect of material transfer and assembly in the production line. Before starting the setting operation, let's first look at the simulation effect that this case aims to achieve. Based on the simulation effect, let's take a look at the specific operational steps. We will now start demonstrating the specific operational steps. Open the case model, click on the application module, and then click on More to enter the MCD module under Mechatronics Concept Designer. Next, we will set up basic mechatronic objects such as rigid bodies, collision bodies, actuators, and sensors. First, set the parts that have physical significance or can move as rigid bodies. Click on Mechanical in the menu bar and select Rigid Body. Choose Automatic for Mass Properties. The default material for the rigid body is steel, and it automatically calculates the center of mass position. In the Assembly Navigator's part list, set the unassembled material part as a rigid body and name it RB1, unassembled material. Then, set the assembled material part as a rigid body and name it RB2, assembled material. After setting moving parts as rigid bodies, since they are subject to gravity acting vertically downwards, we need to set the models that collide with each other as collision bodies. Next, in the Assembly Navigator, select these two blocks and set them as collision bodies. The collision shape of collision bodies can be set according to needs. Click on the Physics Navigator, and we can see the basic physics that have been set. Then, in the Model view, set collision bodies from left to right in sequence. Click on Collision Body and set the upper surface of the conveyor belt on the right as a collision body, naming it CB1 Conveyor Belt 1. Then, set the upper surface of the conveyor belt on the left as a collision body, naming it CB2 Conveyor Belt 2. After completing the settings for collision bodies, proceed to configure the actuator's transport surface. Set the conveyor belts as transport surfaces to enable their transmission function. Click on Transport Surface under the inverted triangle symbol below Position Control. Set the upper surface of the conveyor belt on the right as a transport surface, with the direction along the negative x-axis and parallel velocity set to 200, naming it TS1 Conveyor Belt 1. Set the upper surface of the conveyor belt on the left as a transport surface, with the direction along the negative x-axis and parallel velocity set to 200, naming it TS2 Conveyor Belt 2. After completing the actuator settings, proceed with the sensor configuration. Click on Collision Sensor, select the cylindrical part of the sensor at the end of the right conveyor belt, and set it as the sensor for the transmitter entry. In the Collision Shape drop-down menu, select Cylinder, and in the Shape Properties drop-down menu, select User Defined. This will pop up the sensor's relative coordinate system. The height in the z-direction of the coordinate system represents the detection range of the sensor. To ensure effective detection of materials, set the height to 100. Then click Apply once named.